The calculus of naval warfare is often reduced to a single brutal equation. On one side of the equal sign is the tensile strength of face-hardened steel armor. On the other side is the kinetic energy of an incoming projectile. On December 8, 1914, the German armored cruiser SMS Scharnhorst found herself on the wrong side of this equation. She was the flagship of the East Asia Squadron, a vessel designed for commerce raiding and colonial patrol. She was swift, well-drilled, and lethal against her own weight class. But when she approached the Falkland Islands that morning, she did not find a soft target, a wireless station to silence, facilities to wreck, or coal stocks to seize. She found the tripod masts of British battlecruisers. The sight of those tripod masts collapsed the situation into the same brutal math: speed, range, and inevitability. Admiral Maximilian von Spee read it at once from the bridge of the Scharnhorst. Vice Admiral Doveton Sturdy's battlecruisers, HMS Invincible and HMS Inflexible at their head, were faster, heavier, and closing. In a matter of hours, they would run the Germans down. So he acted. He ordered his light cruisers to detach and flee into the open Atlantic. Then he turned the Scharnhorst and her sister ship, the Gneisenau, directly toward the pursuing giants. It was a sacrifice, made to buy minutes. What followed was kinetic overmatch in its purest form. The Scharnhorst carried roughly 6 inches of belt armor, enough against medium-caliber fire. Sturdy's battlecruisers answered with 12-inch shells. Each one weighed 850 pounds, more than double the mass of the German return fire. At extreme velocity, that kind of weight does not punch a neat hole. It hits like a hammer blow that spreads through steel, warping frames, loosening rivets, and turning single impacts into cascading failure. Then the punishment began. For over 3 hours, the Scharnhorst absorbed this punishment. The German 8.2-inch guns struggled to bridge the gap. The crew of the Scharnhorst continued to load and fire until the ammunition hoists were smashed, and the turrets were disabled by the concussive force of near misses and direct hits. The upper works of the ship were reduced to a twisted lattice of iron. Smokestacks collapsed. Fires raged unchecked as damage control systems failed. Lines ruptured, pressure dropped, compartments flooded, and the crew lost the ability to fight multiple blazes at once. By 4 o'clock in the afternoon, the list to port became irreversible. The engineering spaces were flooding, not from a single hole, but from the cumulative failure of the watertight compartments. The pumps could not compete with the volume of the Atlantic Ocean entering the hull. By 4:17 in the afternoon, the Scharnhorst fell silent. She rolled onto her beam ends, flag still flying, and within moments she was gone, swallowed by the South Atlantic. There were no survivors. About 860 officers and men, including the admiral, went into the freezing water and did not come back. The ship did not simply sink. She disintegrated into a wreck as she went down, carrying a precise geometry of damage into the dark. The sea closed over the site with no marker, no buoy, no clean point to return to. In the chaos of the remaining action, even the coordinates of her final turn blurred and drifted on paper. Scharnhorst vanished from surface war and became a problem of hydrography and depth. The South Atlantic is not a stable laboratory for forensic archaeology. Weather windows here are brief, violent, and unpredictable, and a salvage vessel working southeast of the Falkland Islands can be pinned down by sea states that halt operations for weeks. Even with modern sensors, the hunt is still defined by uncertainty. A wide grid, imperfect wartime positions, and only a narrow stretch of workable weather to collect clean data before the surface turns hostile again. To find a ship that sank during a running gun battle, a surveyor must first construct a search box. This is not a specific coordinate on a map. It is a probability grid derived from the chaotic data of 1914. The British logbooks recorded positions under fire through dead reckoning, bearings, and estimates. And when cloud and smoke stole the sky, even the clean certainty of celestial fixes could vanish. These records contain inherent errors. A navigator on a bridge under shell fire is less precise than a navigator in peacetime. The search team had to overlay these conflicting accounts to define a square of ocean where the probability of the wreck existing was highest. This box covered a vast area of the seabed, and the target lay deep, about 1,610 meters, roughly 5,280 feet. Down there, sunlight is absent, and the water hovers near freezing, slowing corrosion even as it preserves the wreck in the cold. But the pressure at that depth is immense, exerting over 2,000 pounds per square inch on every surface. The deep is hostile. It crushes weakened structure and collapses any sealed spaces that are not pressure compensated. And physics was only the first constraint. The mission was further constrained by a barrier that had nothing to do with physics. The Scharnhorst is a sovereign German warship and a tomb for the men who went down with her. As a general rule, sunken state warships are regarded as remaining under the authority of their flag state unless formally abandoned, and expeditions treat such sites with that legal and human weight in mind. In a commercial salvage operation, the goal is often to cut, lift, or penetrate the hull to recover cargo. Here, the operating policy was non-disturbance. The expedition imposed a strict look but do not touch protocol. The survey team would not retrieve a bell, a gun sight, or a personal artifact to prove identity. Physical evidence had to remain on the bottom. This meant that proof had to be visual. Cameras and sonar capturing enough detail to match the wreck against archival references without disturbing the site. The mission objective was strictly data acquisition. More than a century had passed since the sinking. Time acts as a slow solvent on steel ships. The superstructure of a warship is often light and brittle, while the hull is heavy and armored. As the ship descends through the water column, the drag tears away masts, funnels, and bridges. The impact with the bottom creates a debris field that can spread over acres. The searchers were not looking for a pristine ship sitting on the sand. They were looking for an anomaly in the sediment that matched the acoustic signature of an armored cruiser. A search box can be drawn cleanly on paper, but the seabed is ridges, canyons, and mud that do not care about theory. A magnetic spike or a sonar contact might be iron, or it might be geology. The team had to separate rock from wreck by hunting for the one thing nature rarely offers down there: straight lines and right angles. They had to cover the grid before weather or money forced them off station. And the deep ocean does not give up a century-old secret easily. To see the bottom of the ocean, light is useless. Photons are swallowed by seawater within a few hundred feet of the surface, and by the time you reach the depth where the German squadron lies, the world is lightless. So the survey team worked with sound instead, building maps from echoes, not images. For that job, they relied on autonomous underwater vehicles. The seabed constructor, the host vessel for the expedition, carried a fleet of these machines. An autonomous underwater vehicle has no tether to the surface. It is a drone, a torpedo-shaped machine roughly 20 feet long, packed with batteries, navigation computers, and high-resolution sonar, including synthetic aperture systems on some platforms. Once launched, it dives to the seabed and runs a pre-programmed mission, navigating crushing pressure without real-time input from a pilot. The seabed constructor deployed 4 of these units simultaneously, creating a swarm that could scan vast areas of the ocean floor in parallel. The search pattern used is known in the industry as mowing the lawn. The robots fly in long, parallel tracks, overlapping their sensor swaths to ensure 100% coverage of the search box. This is a game of geometry and patience. The AUV emits pulses of high-frequency sound directed sideways. When these pulses hit the flat mud of the abyssal plain, they scatter and return a weak signal. When they hit the vertical steel plating of a shipwreck, they return a hard, bright echo. Behind the hard object, the sound is blocked, creating a long acoustic shadow. By measuring the length of this shadow, the analysts can calculate the height of the object protruding from the mud. For days, the data revealed nothing but the geological noise of the seabed. The robots returned, were recharged, their data downloaded, and launched again. The monotony of the side-scan sonar waterfall display is the primary enemy of the analyst. Hour after hour of gray noise can induce fatigue, causing the human eye to miss the subtle signature of man-made debris. Then, on the 3rd day of the search, AUV number 1 deviated from its primary track to perform a turn. In a standard grid search, the turns happen outside the high probability zone to conserve battery power for the straight lines. However, during the specific turn maneuver, the side-scan sonar swept across a sector of the bottom that was technically outside the primary search lane. The sensors registered a massive disturbance. The image that appeared on the screens in the control room was not a rock formation. It was a chaotic smear of hard returns surrounded by a distinct debris field. The acoustic shadow indicated a large, linear structure standing proud of the sediment. It was not a biological shape. Nature rarely creates straight lines or perfect right angles. The target was substantial, suggesting a vessel of significant displacement. The AUV had found a ghost, an unmistakable disturbance in the seabed, heavy enough to cast a long acoustic shadow. The contact sat where the drifted positions of the 1914 fight said it might, but sonar is evidence, not identity. In waters marked by traffic and conflict, a bright return is only a lead until steel details confirm it. So the seabed constructor recovered the drone and shifted from listening to looking. The team deployed a remotely operated vehicle, tethered to the mothership by a fiber optic umbilical, streaming high-definition video in real time to the control room. Then it began the descent. The descent takes time. As the vehicle falls through the water column, the pressure builds, and the light from the surface fades into absolute black. When the pilots finally activated the floodlights near the bottom, the beam illuminated a scene of preserved violence. The hull of the ship loomed out of the darkness, upright and proud on the sediment. In the cold, deep water, the wreck appeared to have held its shape, battle-scarred, stripped of much of its superstructure, but still unmistakably a major warship. The first sweep was immediate and practical. In 1914, many warships carried visual identifiers, a name board, a crest, a distinctive fitting meant to be seen at a distance. On the Scharnhorst, a prow emblem associated with her namesake could have made the case far easier. The lights swept over the vertical edge of the bow. The steel was bare. Whatever once marked the ship, name, crest, or ornament, was not there to be seen. Whether it was torn away by battle, stripped during the sinking, or lost over a century on the seabed, its absence created an immediate crisis of evidence. Without an obvious identifier, the wreck was simply a Scharnhorst-class cruiser. This distinction is critical because the Scharnhorst was not alone when she died. Her sister ship, the Gneisenau, was sunk in the same battle, roughly within the same operational area. The two ships were built to identical specifications. They shared the same hull form, the same 8.2-inch main battery, and the same silhouette. Finding a wreck was not enough. The team had to prove which sister lay before them. This challenge introduced the concept of forensic exclusion. In maritime archaeology, when a positive identifier like a bell or a nameplate is missing, the surveyor must identify the ship by proving what it is not. They must find a structural anomaly or a modification that exists on one ship but not the other. This requires a deep knowledge of the blueprints and the refit history of the class. The team had to look for subtle differences in the arrangement of steam pipes, the location of cowl vents, or the specific layout of the secondary armament. The inspection continued, moving aft along the deck. The cameras revealed details that were haunting in their clarity. Near the bow, sections of wooden decking appeared intact and surprisingly clear of marine growth. The superstructure was stripped and broken, but the hull still read as a warship in silhouette, scarred, reduced, and upright in the dark. But these details, while atmospheric, were generic to the class. They did not separate the flagship from her sister. The remotely operated vehicle circled the wreck looking for a fingerprint. The dispute in the control room was one of caution. To announce the discovery of the Scharnhorst and be wrong would be a professional catastrophe. The Gneisenau was a hero ship in her own right, but she was not the admiral's flagship. The history books recorded that the Scharnhorst sank first and the Gneisenau sank later, potentially miles away. But in the fog of war and the drift of the currents, positions are estimates, not facts. The team needed a feature that could not be replicated, something built into the ship that time could not casually erase. Without an obvious marker, the only honest path was forensic comparison. They went back to the blueprints and refit history, hunting for small, stubborn differences. The placement of vents, the routing of pipes, the geometry of openings. They had to count unmoving steel and match it against archival drawings of 1907. The resolution to the identity crisis did not come from a nameplate. It came from the unalterable geometry of fittings and openings in the hull plating. While the Scharnhorst and the Gneisenau were sisters, they were not identical twins. They were built in different yards, the Scharnhorst at Blohm and Voss in Hamburg, and the Gneisenau at Weser in Bremen. In 1907, slight variations in details could exist even between ships of the same class. The survey team pulled the original shipyard references for both vessels and placed them side by side. The discrepancy lay in the positions of the upper portholes along the hull. Old photographs and reference drawings showed a pattern on the Scharnhorst that differed just enough from the Gneisenau to act as a fingerprint. The team directed the remotely operated vehicle to hover alongside the starboard quarter. The cameras focused on the row of circular openings in the steel. The pilots counted them slowly. 1, 2, 3. They matched the spacing and the number on the Blohm and Voss drawings perfectly. This was the forensic fingerprint. It was a detail that no amount of battle damage could erase and no amount of corrosion could fake. The wreck was definitively identified as the Scharnhorst. The doubt that had lingered since the discovery of the missing crest evaporated. With the identity locked, the survey shifted to documentation. The cameras panned to the gun positions. The main forward guns sat at maximum elevation, and the smaller side station guns lay nearer horizontal, a posture frozen by damage, mechanics, and the last geometry of action. It was a visual clue, but not a confession. Either way, the wreck preserved the posture of violence. The survey team now faced the second half of their mission mandate. In a commercial salvage operation, identification can be the starting gun for cutting and recovery. Here, it was the line they could not cross. Scharnhorst is a war grave, a sovereign German warship, and a tomb for the 860 men who died inside her hull. And the decision was made before the expedition ever sailed: disturb nothing. The team documented what they could see. They mapped impact points from 12-inch shells and traced the collapsed superstructure in high-definition video, but they never used a manipulator to lift silt, never took a sample, never removed an artifact. The only thing the seabed constructor took from the bottom of the Atlantic was terabytes of data. When the survey was complete, the pilots engaged the thrusters to lift the vehicle away from the seabed. The lights of the robot receded and the Scharnhorst returned to the darkness. The ship had been found, named, and inspected, but she had not been disturbed. The paradox of modern oceanography is that we can see everything, but we must touch nothing. The team had solved the mystery of her location, but they left the ship exactly as the ocean had held her for a century. The cameras of the remotely operated vehicle were the last eyes to see the Admiral's flagship. As the machine winched back to the surface, the Scharnhorst returned to a solitude that had lasted for more than a century. The heavy steel hull, the guns trained out in defiance, and the shattered superstructure were swallowed once again by the absolute darkness of the South Atlantic. The interior of the ship remains a forbidden zone. The armored doors are rusted shut. The magazines, the engine rooms, and the bridge where Admiral von Spee gave his final orders are sealed by pressure and time. We know where the ship lies, but we will never know the specific narrative of the final moments inside those compartments. The legacy of the expedition is not a physical artifact. There is no brass bell in a museum, no teak planking on a display stand. What came back to the surface was information, high-resolution video and sonar maps dense enough to rebuild the wreck as a digital twin. That model lets historians and naval architects study damage and structure without violating the sanctity of the site. It preserves the ship exactly as she was found, a frozen moment of 1914 that will not corrode or decay inside the archive. This approach represents a fundamental shift in how we treat maritime history. In the past, success was measured in tonnage lifted. It was about recovering gold or steel or guns. Today, the success of a deep ocean survey is measured in the clarity of the data. And in practice, the Scharnhorst is treated as a war grave, a sovereign state warship, and a protected place of memory. The trust behind the expedition has been seeking formal legal protection to reduce the risk of future disturbance. It acknowledges that the wreck is not merely a collection of rivets and armor plate. It is the final resting place of about 860 men. The violence that sent them to the bottom was industrial-scale warfare, a clash of empires measured in shell weight and steel thickness. But the site today is defined by silence. Marine life clings to armor plate without memory, and cold currents sweep the hull with indifferent force. The debris field still sketches the energy released when the ship died, scattered across the seabed like a diagram drawn in darkness, one that will never be redrawn. Admiral Maximilian von Spee is often remembered for his tactical brilliance and his refusal to surrender against overwhelming odds. The discovery of his flagship brings a geometric precision to his end. We now know the exact angle of the list. We know the orientation of the guns. We know that he fought the ship until the physics of buoyancy made fighting impossible. The discovery does not change the outcome of the Battle of the Falkland Islands, but it adds a final physical footnote to the historical record. The precise coordinates of the wreck are held close by the expedition and the heritage authorities, shared only as appropriate. What protects the site is not a patrol ship on the horizon, but a framework of law, sovereign immunity in practice, and a simple operational choice: leave a war grave undisturbed. The Scharnhorst will likely remain on the bottom for generations, slowly dissolving into the sediment as the iron oxidizes. The mission to find her was a technical triumph of acoustics and robotics, but the decision to leave her alone was a triumph of respect. The ocean keeps the ship, and the history books keep the data. The patrol of the East Asia Squadron is finally and officially over.